Today, let's talk about different types of variables, mostly specifically discrete versus continuous variables. So, discrete. A continuous variable versus a discrete variable. So, a discrete variable means there is a finite or an actual number that you could choose for that type of variable. For example, um, let's say one of your classmates likes to read books, or you like to read books, and you say, okay, within this week, I've read 3 books. That is a discrete variable. You can count precisely how many books, right? So, a number of objects. So, for an example, that would be a number of books. So, discrete would be the number of books. However, if that same student said, well, I read for about this much amount of time, that is a continuous variable because time is not precisely finite, right? If you think about um, time in itself, you got minutes, you got seconds, you got milliseconds, you got nanoseconds. What is the amount of time that you spend on something? Well, that could range. That is continuous, right? That variable is continuous. You can't say this is exactly 1 minute, 0,000. That's just it. There is a more to it. So that would be the difference between discrete and continuous. Discrete, if you can think of it as a whole number, it is discrete. However, if you could break that number down into multiple different parts, like minutes, years, whatever, what have you, then it would be a continuous. So just like with the time, age, age is continuous because it always changes. You aren't exactly, say, 17. You are not exactly 17. You are 17 years, so many months, so many days, so many hours, so many minutes. It is continuous. That variable is continuous on and on. Next, let's go on from variables. Let's talk in terms of standard deviation and different types of graph. This graph that I have up with me is called the normal graph or the normal distribution, meaning it's a unimodal, it's symmetric, everything is pretty much in the center. How to tell? Let's say if someone gave me a bit of information and they're like, hey, what kind of graph is this? How would I be able to tell if it's a normal graph? Am I dealing with a normal graph? Am I dealing with a skew graph? And what kind of skew is it? Well, let's give an example. But first, let's look at our normal graph. Each one of these spaces in the normal graph represents one standard deviation. So this is one standard deviation. This is another one, another one, another one, another one, another one. So in a normal graph, if the mean or the median in the median in the normal graph, right, is what, 1, 2, 3, at least 3 standard deviations from the start or the end, then you can assume it is a normal graph. However, if it is more than 1 standard deviation, if it is more than, say, 3 standard deviation from zero, then it will be skewed to the left. If it is less than 3 standard deviation from zero, then it will be skewed towards the right. Let me give you an example. Let's say it's fall is coming up. Let's talk about apples. Let's say we had a whole bunch of varieties of apples, and the median number of apples was, let me use a different color here. The median was, okay. Let's say the median is 10. Okay, the median was 10, and our standard deviation was, uh, let's say the standard deviation was 2. Our standard deviation is 2. So to get from our standard deviation to the median, that is what? 5 standard deviations? That's 5. That's a whole bunch. So if you look over here, that means if I had to kind of draw that graph in mini, that's 1, 2, 3, 4, 5, all the way 5 before I actually hit the median. So if I had to guess, this graph is going to be skewed towards the left, because the tail is pointing our left. However, let's say the standard deviation is, let's say our standard deviation is then, let's say 3. That means here we get what, from 10 to the middle? We have 1, 2, 3, right? Until we get close to the median. Well, that is close to our normal standard deviation. So our normal graph, so this one is actually normal. But what, let's say our standard deviation is, let's say it is 4, right? Our standard deviation is 4. That means it's like 2.5, 2 before you hit the median. So it's less than 3. So our skew will be more towards the right. Okay. So here, knowing where our median is and knowing how big our standard deviation is and how many spaces are can tell us what type of skew we actually have. Okay, and that is all.